Okay, to finish up 5.1, we're going to end with the third method of finding probability with the normal curve, and this is going to be the calculator function. Okay? Your calculator function is going to be a lot easier because you just need to worry about what area are you looking for under the curve. The mean, the standard deviation is going to be given to you again. You need to worry about, okay, am I looking for greater than this value, less than this value, or between? Very similar to what we did for z-score. Okay, still looking for that area, but now the calculator's on to do that work for us. Okay? The calculator function is the normal CDF function. Okay, so normal CDF, and it should be under the distribution function. There should be a button that has VARS, that's the variable button. The second value of that is going to be the DIRST, the distribution value, okay, distribution menu, and it should be the second one there. So if you go to it, on your screen should show up normal CDF if you have one of the older calculators. And the older calculators, you plug in the lower limit, comma, upper limit, comma, mean, comma, and then your standard deviation. If you have a newer calculator, it's going to ask you in a list, lower, upper, the mu symbol, and then your sigma. It's going to ask you to list those, and then you paste them in, okay? And the calculator will paste them in to the correct order here for you, okay? So it's not dependent on which calculator you have. Both the function does the same thing. You need the same pieces to get the answer. Problems are going to look the same. The average person can spit 6 feet with a standard deviation of 0.82 feet, okay? So the average person, we have our mu of 6 feet. Sigma is 0.82, sorry, the point got left over there, 0.82 feet. Okay, the question I was saying, what is the chance of finding someone who can spit between 6.2 and 6.9? If I did draw my curve, okay, I have my 6.2, my 6.9, and I'm going in between. Well, right there's my lower and upper bound. Lower bound, upper bound. It's in between the area that I'm looking for. So if I'm using this in the normal CDF, I'm going to plug in. My lower bound is 6.2, comma. Upper bound is 6.9, comma. The average was my 6 feet, and my standard deviation was 0.82. Close parenthesis. And if you enter that in, you should get 26.746. So that's if it's giving you both boundaries, lower and upper. What's the chance of finding someone who can spit over 5 feet? Well, over 5 feet. There's my curve in that case. There's my 5, and it's going up. The 5 is the lowest number, so that is my lower boundary. My upper boundary, actually, there is none. It goes on forever. Realistically, can someone spit forever? No, but looking at my chart, it could go on forever. Now, the way I'm going to deal with that, okay, my lower boundary I know is 5. For my upper boundary, I'm just going to put some obnoxiously big number. I'm going to put a number that's way off my chart. Okay, I know it's far off there, so just some huge number so I know it's not going to affect it. If you pick a number that's too close, it may cut off a little bit of the tail end and affect your probability. So I usually just go obnoxiously big, just put a whole bunch of 9s. My average is still 6, standard deviation is still 0.82. And that's going to give me a 88.868%. Okay, so there we go with that. Okay, now, if it was asking for a less than, okay, so we had an upper bound and not a lower bound, I'm just making my obnoxiously big number in my lower bound, but I'm making it negative. I would put negative 9999 and then have my upper bound be the value that it is. Okay. So there's the calculator function. And the one last thing I want to talk about is percentiles. We talked about quickly when we looked at z-score. That chart gave us our percentile. Okay? For the z-score, you looked at the chart and that was from that probability down. Okay? The percent is below the score and everything else is above. Okay? So if we're looking at what percent of class do you want to be in when talking about grades, you want to be in the high percentile. Okay? You don't want to say, okay, I'm in the first percentile. First percentile means there's only 1% below you. Okay? If you're thinking of percentiles, I want to be in the 99th percentile. That means 99% is below you and only 1% is above you. Okay? So you always want to think about percentile is everything below what the value is. Okay? John is proud to tell people that he is in the 15th percentile for yearly income in his neighborhood. Should John be proud? Justify your answer. Okay? Now I know money's not everything. I don't want to say that's all I'm thinking about here. But at the 15th percentile, there's 85% of people higher than him in his neighborhood that are making more money than him. Okay? So it might not be something to brag about. It might actually be a motivator. But make sure you're thinking, okay, 15th percentile. There's 15% below you. There's 85% above. Okay? So that's percentile and the calculator function. So now you know your three methods that we're going to be using in this class, using the normal curve to find probability.